In section 5.4, the discussion is about special products. Well, there are three special products that are discussed. The first one is a special way to multiply two binomials, and it's called the FOIL method. It's FOIL just is an acronym for a way for you to remember how to multiply two binomials. We just did in 5.3, we talked about how we could multiply two binomials just by using the distributive property. But FOIL is just another way of doing the same thing, and many times it's easy to remember an acronym, and so that's why this one is given to you. So the FOIL method is only used, you have to remember, it's only used to multiply two binomials. So if they're not two binomials, you cannot multiply them using the FOIL method. But FOIL stands for F-O-I-L, and F stands for the product of the first term. So imagine you have two binomials. Like here, this is a binomial 3x plus 1, and this is a binomial 2x plus 5. FOIL stands for first. F stands for first. It means multiply the first terms in both the binomials. Notice they're highlighted in blue. The first term times the first term, and get that product. Then O stands for the outer terms. That means on the outside, the outer edges of the parentheses. They're not outside the parentheses, but they're on the outer edge here and there. The 5 and the 3x are on the outer edges. I stands for inner, so you multiply the two terms that are on the inner, like right next to each other, the 1 times the 2x. Then L stands for last, so you multiply the two last terms in each binomial, the 1 and the 5. So that's the process. You always go to FOIL. You do first, outer, inner, and then the last. And then you combine the terms that can be combined after that, if there are any like terms. And one thing you know, when you do FOIL or use the distributive property to multiply two binomials, you're going to always get 4 terms. Notice down here, we end up with 1, 2, 3, 4 terms. Now, after you get those 4 terms, many times 2 of the terms will combine because they're like terms. But you always should at least get 4 terms when you multiply a binomial times a binomial. And then it may simplify to 3 terms. Okay, so let's look how this FOIL is done. So let's do quickly the FOIL method. First times first. First times first means x times x. So that gives us x squared. Okay, F is FOIL is F-O-I-L. O is outer, so the two outer terms, x times negative. Now you have to look at that as negative 5, so that's negative 5x. Then the inner, 7 times x, so that's positive 7x. And then the last would be 7 times 5. So that's 7 times negative 5, my bad. It's negative 35. Okay, so now we can combine whatever like terms we have. We have some x terms, negative 5x plus 7x is plus 2x, and then minus 35. So when you multiply the two binomials using FOIL, you are going to end up with terms that are like, that you can combine, and you ultimately end up with a trinomial. Okay, let's FOIL again. First times first gives us 6x squared. Outer gives us 6x times negative 4, that's minus 24x. Inner is negative 1 times x, that's minus x. Last is negative 1 times negative 4, that's plus 4. Notice the two middle terms are both x terms, so we can combine them. They have the same variable raised to the same power. Negative 24x minus x is negative 25x plus 4. Okay, so we've multiplied using FOIL. Now here we've got three terms, well, two binomials and an extra factor here. So honestly, you could multiply the 3 times x minus 4 first and then FOIL those two remaining binomials, or you can FOIL these binomials as they appear here first, and then whatever we get, multiply that times 3. So let's do that. Let's FOIL this. X times 3x is 3x squared. Outer would be x times 1, so that's x. Inner would be negative 4 times 3x, so that's minus 12x. And then last would be negative 4 times positive 1, that's a negative 4. And all of that is to be multiplied by 3. Okay? You understand what I just did? Now let's simplify this one. 3x squared. X minus 12x is minus 11x minus 4. That is being multiplied by 3, because that's the 3 that we have out front over on the left problem written in red. That's the same 3. So now we have to distribute the 3. We're going to multiply 3 times each one of these terms now. All right? So 3 times 3x squared, 9x squared. 3 times negative 11x minus 33x. 3 times negative 4 is minus 12. So we've multiplied our terms, and then we multiplied it to distribute the 3. Now notice what happens here. We have a binomial squared. We're squaring a binomial, which means multiplying that binomial times itself. Now, there's a pattern that emerges every time you multiply a binomial times itself. Every time you square a binomial, the same pattern happens. And watch what it is. What happens if we were to FOIL this? 2x plus 5 times 2x plus 5. Notice what we get. I'm going to use some colors here. When we do first times first, we get 4x squared. Okay? When we do outer times outer, we get what? 2x times 5 is 10x. Right? But notice what happens when we do the inner. We're FOILing, remember? When we do the inner, we get 5 times 2x, which is another 10x. Okay? Then we have 5. For the last, we get 5 times 5, which is plus 25. Look at it and see where these terms come from. So we FOILed them. Notice that 4x squared is a square term, because the 4 squared is a square number and x squared is a square term. So the first term in this polynomial here is a square term. 4x squared is a square term. Notice also that 25 at the end is a square term. 25 came from squaring the 5, multiplying 5 times 5. Okay? So the first term is a square term, the last term is a square term. Look at the two terms in the middle. They are exactly the same. 10x and 10x are 2 of the same thing. 2 of the same thing. 2 of the same thing. There are 2 of those 10x's. How many of those 2 x's do we have? 10 x's? We have 2 of them. So we really could write this as 4x squared plus 2 times 10x plus 25. Because we have 2 of them, right? 2 of those middle terms means 2 times the middle term. Well, let me break it down a little bit further to show you where this came from. Remember the 2x that we had? Well, what do we get when we square it? We get 4x squared. Remember the 5 that we had? What do we get when we square it? 5 squared, which is 25. Oh, this is a mess. Pardon me with all of the erasures. Okay, arrow and then 5 squared. That's where the 25 came from, squaring the 5. Now, where did the middle term come from? The middle term right here came from taking the first term in our binomial, 2x, multiplying it by 5. 2x times 5 is 10x. And then we take that and multiply it by 2. So 2x times 5 times 2 is 20x, which is what we get when we combine those middle 2 terms. So what's going to happen? Seems like a whole lot of mumbo jumbo now. But what happens when you have a binomial and you square it? You take the binomial, you look at the first term in the binomial, you square it. You look at, let me point it out to you. Look at the first term in the binomial, like in this definition here. It's a. To square it, you multiply a times a. First term, square it. Last term, you square it. B squared gives you the last term. The middle term takes a times b. This a times this b times 2. 2 times a times b. And that's going to be your middle term. Just like, look at mine up at the top. 2x, we squared it. That gives us 4x squared. 5, we squared it. That gives us 25. Then I take 2x times 5. The a times the b times 2 gives us 20x in the middle. So if you recognize this pattern, when we square a binomial, we get something called a perfect square trinomial. Perfect square trinomial. And it works if the sign in my binomial is positive or negative. It's just that if the binomial has a subtraction in it, then you know that your second term in your product is going to be negative. It's going to take a minute to be able to recognize it, but I promise you, if you do, it's going to help you later on when we get to chapter 6. So, squaring a binomial is equal to the square of the first term plus or minus twice the product of both terms plus the square of the second term. Let's see it in action. All right, I've written the patterns up top here. So I want to multiply this out without going through foiling. The thing is, if you don't remember this pattern, you can always FOIL this out and understand that you can multiply it that way. Y plus 3 squared the whole quantity squared, is the same as y plus 3 times y plus 3. But I don't want to go through all that. I want to use the pattern. What is my a? Y. What do I do with a? I square it. So y squared. My second term is 2 times. It's going to be positive because this is positive. 2 times what? Y times 3. 2 times, I multiply the two terms. Y and 3, I multiply them. 2 times y times 3. So that's 2 times 3y. And my third term is going to be plus 3 squared. Okay, so that gives me y squared plus 6y plus 9. And we just multiplied it. Okay, I'm going to do the next one, but I'm going to go straight forward with it. I'm not going to separate it into 2 times anything. I'm just going to do it. Watch. Multiply b plus 3 whole quantity squared. Gives me the square of the first plus 2 times b times 3, which is 6b, plus 9. If you don't believe me, go and FOIL it and see what you get. You get b plus 3 times b plus 3. FOIL it. You get b squared plus 3b plus 3b plus 9. But the 3b's add together because they have the same, they're like terms. So we get b squared plus 6b plus 9. But I went straight from here to here without doing all that foiling, if you understand the pattern. So it takes some time. You have to do the exercises in order to get it down, okay? I'm showing you how to do it. You have to do the practice in the homework. Here's another one. X minus y squared, quantity squared. So I'm going to square the x plus 2 times x times, I'm sorry, it should be minus. Should be minus because my sign is minus in here. 2xy plus, though, y squared. The last term is always positive. The middle term in your answer can be negative or positive based on the term, the sign in the binomial. But the last term here has to be positive because remember where it's coming from. It's coming from squaring a number or a term. And remember what square means. It means multiply it by itself. So even if the y was negative, what's a negative y times a negative y? It's a positive y. If the y was positive and we were multiplying it, positive y times positive y is positive y. So always when you're squaring a binomial, your last term has to be positive. That's one way you know if you've messed up. If your last term comes out negative, you've done something wrong. So let's see. We have 3y plus 2 whole quantity squared. I'm going to square the 3y. What's 3y squared? That's 9y squared. Remember, I have to square the 3 and square the y. Plus 2 times 3y times 2. Well, 3y times 2 is 6y, and that times 2 is 12y. Then I'm going to square the 2, which is 4. Okay, we took 3y, we squared it. That became our first term. That gave us a 9y squared. We took the 2 and squared it. That gave us our last term. Then our middle term came from these two multiplied together and then multiplying that times 2. and that gave us the 12y in the middle. All right, here's one more. Now, I'm going to ask you, what's the a and what's the b? Remember, our formula says uses a's and b's. What's the a here? The whole thing must be squared. So a squared is the thing that must be squared. So what do you get when you square a squared? Get a to the 4th. Okay, the middle term is going to be a squared times negative 5b. So that's negative 5a squared b times 2. Remember, it's always times 2. So that's negative, what, 5? Negative 10a squared b. Then we are going to square the last term. What's the last term? Negative 5b, it becomes plus 25b squared. This is one of our special products. Squaring a binomial always goes through this pattern. The sooner you learn the pattern, the more time you will save in solving problems later on. Now watch what happens with this case. Look at this example, x plus 5 times x minus 5. What do you notice about those two binomials? What you should notice that if it wasn't for the difference in the signs, they would be exactly the same. Exactly the same. We have x plus 5 times x minus 5. So what we have is the sum of two terms times the difference of the exact same two terms. The sum times the difference of the same terms. And notice what happens when we FOIL them. If we FOIL them, we get x squared minus 5x plus 5x minus 25. But then what happens to the middle two terms here? One's negative 5x, one is positive 5x. So they are opposites of each other, so they go to 0. So we end up with x squared minus 25. All right? X squared minus 25 is the simplified product of these two binomials. But why go through all of this if I know that there's a pattern? Look at what happens. Every time you multiply the sum of two terms times the difference of the same two terms, the middle two terms go away. They're going to always be opposites of each other. So they go to 0. And all you're left with is the square of the first term. What's the first term? X. So you end up with x squared minus the square of the second term, which is 25. Always, 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 when you multiply the sum times the difference of the same terms, you end up with the square of the first minus the square of the second. And this is called the difference of two squares. Because it's the difference meaning it's subtraction, and the squares means you have an x squared term and a number that's squared. Okay, sometimes it'll be the numbers first and a variable second. But here is what we do in multiplying the sum and the difference of two terms. It's always going to be the first term squared times minus the second term squared. So look what happens here. We have 2 times x plus 7 times x minus 7. Well, we should recognize that this is the sum of two terms times the difference. which we know is going to ultimately give us the difference of 2 squares, but we still have that 2 to multiply it by. So what do we get? The difference of 2 squares. When we multiply, we square the first one, minus the square of the second one. So let's square the first one. X squared is x squared minus 7 squared, but 7 squared is what? 49. And then we have the 2 to multiply, so we get 2x squared minus 98. Okay, so we multiplied the two binomials, came up with the difference of 2 squares, and then multiplied it by 2. It works the same way with fractions. We have the sum of 2 terms times the difference. Now they have to be exactly the same 2 terms in order for this to work like this. So we square the first term, which is x, and square it, minus 1/3 squared. Well, what's 1/3 squared? 1/3 times 1/3 is 1/9. And there you have it. You don't even have to FOIL it. Look at this one. Is it the sum times the difference of the same 2 terms? Sure is. So how do you square the first term? What is the first term? The first term is 2x squared. Well, to square that, remember you have to square it all. So that gives us 4x to the 4th minus 6y squared becomes 36y squared. We're squaring the whole term 6y, and that gives us 36y squared. Now we're going to use whatever special product that is appropriate to use to multiply these. Let's look at the first one. In the first one, are we squaring a binomial? Is it the binomial raised to the second power? No. Is it the sum of 2 terms times the difference of the same 2 terms? No. So is it 2 binomials that we're multiplying? Yes. So we can FOIL them. Remember, FOILing is only used when you have binomials. And since none of the other patterns are going to work here, we have to use FOIL. So let's do first, outer, inner, and last. First times first would be 4x squared. Outer would be minus 24x. Inner would be plus 3x. Last would be minus 18. Then we combine the middle terms. Negative 24x plus 3x is negative 21x minus 18. Okay, the next one is a binomial square. Go back to the formula. When you square a binomial, you square the first term, so we get 49b squared minus, because this is minus, we put minus over here on the other, we put a minus here. Okay, so we have 49b squared minus. Now we have 7b times 2 will be 14b, and then that is multiplied by 2. So that's 28b. Then we have plus 2 squared, which is 4. And there you have it. You've multiplied without FOILing. Remember, you can always go and FOIL if you want to, but this, knowing the pattern, saves you time. What about this next one? Which special product will we use? The sum times the difference of the same 2 terms, because they're exactly the same. X squared minus, now what? 0.4 times 0.4 is point, well, I want to put a 0 first. 0.16. Yep, 4/10 times 4/10 is 16/100. And there we have it. It's a difference of 2 squares. This one is a binomial times a trinomial, so we have to just distribute. So we're going to distribute, and we're going to come up with 6 terms that we have to simplify and combine. So let's see. We get x times x squared, that's x to the third. X times 5x is 5x squared. X times negative 2 is minus 2x. Then we move on to the 1. 1 times x squared is x squared. 1 times 5x is 5x. 1 times negative 2 is negative 2. Then we combine our like terms. We have some x squared terms that can be combined. 5x plus x, 5x squared and 1x squared is 6x squared. Minus 2x plus 5x is plus 3x. Then minus 2. And we've combined all the terms that can be combined. We have it in descending order. So these are your special products: FOIL, squaring a binomial, and multiplying a sum of 2 terms times the difference of the same 2 terms. Go and practice so you can get a handle on this. You will need this in the next chapter.